Hello children. In our previous classes, we learnt about what do you mean by multiples and what do you mean by least common multiple LCM. Let us recall about multiples. When a number is multiplied by any other number, then the product is called as a multiple of that two numbers. For example, here 5 is a number, and when this number is multiplied by any other number, then what we get? 5 into 10 here, 50 we get. Then this 50 is called as multiple of, this is a multiple of 5 and 10. Here we also observe that 5 and 10 are the factors of 50. Factors of 50. 50, the product which is obtained by multiplying two numbers, that number is called the multiple of these two numbers, and these two numbers are called the factors of this number. Okay children, now let us find the first 5 multiples of the number 12. When 12 is multiplied by 1, 12 when multiplied by 1, we get 12. This 12 is called the first multiple of 12. And when 12 is multiplied by 2, then we get 24. This 24 is called the second multiple of 12. Second multiple of 12. Similarly, when 12 is multiplied by 3, then we get 36. This is the third multiple of 12. Similarly, 12 into 4, we get 48. 48 is the fourth multiple of 12. 12 when it is multiplied by 5, we get 60. 60 is the fifth multiple of 12. So here these are the first 5 multiples of 12. One question for you children. How many multiples a number can have? As we are able to see that number can be multiplied by infinite numbers. So the multiples of any numbers, the multiples of any number is infinite. So let us find the LCM of 3 and 6 children. Multiples of 3 we have taken. When 3 is multiplied by 1, we will get 3. When 3 is multiplied by 2, we get 6. When 3 is multiplied by 3, we get 9, and so on. So the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and so on. And we have taken the multiples of 6 also. When 6 is multiplied by 1, we get 6. 6 is multiplied by 2, we get 12. 6 is multiplied by 3, we get 18. And 6 multiplied by 4, we get 24, and so on. The multiples of 6 we got 6, 12, 18, 24, 30, 36, and so on. So here when we take the common multiples of both the numbers, common multiples, what we have common multiples here? See, 6 is the common multiple here. 12 also is the common multiple. Then we can see here 18 is also a common multiple. Okay, and 24 is also a common multiple. And since the multiples are endless, we also get the common multiples of any two numbers endless. Okay children, and here in the common multiples, which is the smallest one? We can see that this is the smallest. The first common multiple will be the smallest one. So here this will be the least common multiple. So here 6 LCM of 3 and 6 is what? 6, least common multiple. So in this way we have learned in our previous classes how to find the least common multiples. But this method is very time consuming and it is not practically applicable for big numbers, isn't it? So we have two other methods to find the LCM of big numbers. Children, as we have seen, to find the HCF of any two numbers, we had two methods, prime factorization method and the other was division method, long division method. So similarly, for finding the LCM of any numbers, we have the same methods, prime factorization method and short division method. Let us take some examples and we'll learn how to find LCM of numbers. Let us find the least common multiples of 6. Let us find the least common multiples of 6 and 9 through prime factorization method. So first we have to prime factorization of 6 and 9 separately. We had here 2 3s are 6 and 3 1s are. Okay. So here we got 2 into 3. Similarly here 9 is not divisible by 2, so we take here 3 3s are and 3 1s are. And here also the prime factorization of 9 is 3 into 3. And here also the prime factorization of 9 is 3 into 3. Now after getting the prime factorization of both the numbers, here LCM will be, first here two steps are involved, children. First one is whatever is common in both the these prime factors, first you write that one. Okay. If you find any common prime factors in both the prime factorizations, you write that number and this number is multiplied by whichever number is not, whichever prime factors are not common, you have to include that prime factors also. So here 2 is there and multiplied by this 3. Okay children. So here whatever common is there, that common prime factor you have to write and this will be multiplied by whatever prime factors are not in common, that also you have to multiply. Here we have 3 2s are 6, 6 3s are 18. So 18 is the LCM of 6 and 9 children. Now this we will find the least common multiples of 6 and 9 through short division method. Short division method, first what we have to do is write the two numbers here. So here we can see children, 6 is divisible by 2, but here 9 is not divisible by 2. So 2 is not the common factor. Next you take the 3. 3 is a common factor of both the numbers. So we have to take it here 3. And 3 words are 6 children? 2. And 3 words are 9? 3 3s are. In this way you need to write children. And here until we get here co-primes, we have to continue. Co-primes. Here we can see that 2 and 3 do not have any common factors except 1, isn't it? So that type of numbers are called as co-primes. So here unless we get the co-primes, you have to do like this and then our LCM will be whatever numbers here we had, these numbers, if you multiply, that will be the LCM of these two numbers. That means here LCM what we have, 3 multiplied by this 2 multiplied by this 3. So here also we had 18. Okay children, we'll see some more examples of finding LCM. Now let us take 3 numbers children. Let us find the LCM of 30, 60 and 90. In prime factorization, if you do prime factorization of these 3 numbers, what we will get? Let us see. 2 15s and here 3 5s and this is 5 1s. So here we have 2 into 3 into 5 and here we have 5 1s. Here we have 2 into 2 into 3 into 5 and this one here we have 2 into 3 into 3 into 5. So 2 into 3 into 5 is the prime factorization of 30. 2 into 2 into 3 into 5 is the prime factorization of 60. 2 into 3 into 3 into 5 is the prime factorization of 90. Now our LCM will be what? Whichever number is common, that one we will take it as only one time and multiplied by. Next common number is 3. Our next common factor is 3. So multiplied by 3. And our next common factor is 5. So I am writing 5 here multiplied by. And whichever number are left over children which are not common, left over 2 and 3. That also you have to write here, included here. Multiplied by 2 and multiplied by 3, which is equal to, we will get 180. So here we can see children, whatever numbers are common in these 3 prime factorization, those were 2, 3 and 5, 2, 3, 5, 2, 3, 5, 2, 3, 5. And which numbers are not common, that numbers are also to be included here. Okay children. So if you multiply all these factors, we get 180. 180 is the LCM of 30, 60 and 90. Now let us do in short division. Now let us find the least common multiple of 30, 60 and 90 in short division method children. We write the 3 numbers here, separating them with commas like this. And what are the common factors from these 3 numbers? We get the first prime number which is common to these 3 numbers is 2. So we write 2 here. And 2 wadza is 30 here, 15. So we write 15 under the 30 here. And 2 wadza 60, 30. So we write 30 here. And 2 wadza 90, 45. So we write 45 under this 90. Okay. After writing like this, we have to again check which are the common factors. Okay children, here we are able to see that 5 is the prime number which is common. So I am taking 5 here. 5 watts is 15, 3s are. 5 watt is 30, here 6. And 5 watts are 45, 9. And here again we can able to see that here 3 is the common factor of 3, 6 and 9. So I am taking here 3. 3 1s are, 3 2s are and 3 3s are. Now here there are no common factors of these numbers. That means here we got co-primes. So we have to stop it here. Co-primes we got, no? So we have to stop it here. And now these all numbers we have to multiply. That will be our LCM. So here LCM is equal to 2 into 5 into 3 into 1 into 2 into 3. 2 into 5 into 3 into 1 into 2 into 3, which is equal to 180. Now let us find the least common multiples of these numbers: 24, 20, 28, 32. Four numbers are there, children. So when we take prime factorization of all these numbers, what we get? 2 12s are, 2 6s are, 2 3s are. So here 3 1s are. So what we got here? 2 into 2 into 2 into 3. This is the prime factorization of 24. Next we'll take the number 20. 2 10s are, 2 5s are, and 5 1s are. So here we get 2 into 2 into 5. This is a prime factorization of 20. Next, for the 2 which is common for only these two prime factorization, we write only 1 2 here and multiplied by. Now here we can see that no the leftover numbers like 3 and here 5, here 7, here 2 and another 2. These numbers are not common anywhere, but we have to include these numbers also here. So what is that? 3 multiplied by this 5 multiplied by this 7 multiplied by this 2 and multiplied by this 2 also. So now these all if you multiply, we will get 3360. Okay children. So here 3360 is the LCM of these four numbers. Children, let us take one more example of six numbers. We have to find the LCM of these numbers: 9, 12, 24, 36, 45 and 54. Now we have to take all the prime factorizations of all these numbers. By taking this prime factorization of all these numbers, we get here. So here these are the prime factorizations of these all numbers, children, we got. And by this what we will get the LCM? LCM is equal to, now 3 is common in all of these prime factorizations, this 3. So I am writing 3 multiplied by, here one more 3. This 3 is, the second 3 is common in all these. So I am circling. For the second 3, this one here and here, it is common. So I am writing 3 here. Next, 2, 2, 2 is common, and here also 2 is common. So I am writing 2 here and multiplied by, here 2 and this 2 and this 2. I am writing 2 here again, and Next, here we can see that this 3 and this 3. I mean, whatever prime factors are common, at least in two prime factorizations, we have to take that number here, children. Okay. Next, we can see that only the leftover numbers are what? 2 here and 5 here, isn't it? So, which are not common and leftover, that also we have to include here in this multiplication. 2 also you have to write, and this 5 also you have to write here. Now we got 3 into 3 into 2 into 2 into 3 into 2 into 5, which will be equal to 1080. So 1080 is the LCM of 9, 12, 24, 36, 45 and 54. In this way we should find the LCM of prime factorization method. Now let us find the LCM of these numbers by short division method, children. I have already written all these numbers separated by commas, and here we can see that only 12, 24, 36 and 54 are even numbers and are divisible by 2. So 2 is a common factor of these numbers. I am taking 2 here. And suppose if the other numbers which are not the 2 is not the factor of 9 and 2 is not the factor of 45 also, the same numbers we write here, children. Okay, this one also the same numbers we write, and the remaining what we do, 2 words are 12, that one we will write here. 2 6 are 12. Next, 2 12s are 24. Next, 2 18s are 36, and here 2 27s are 54. Okay, children, in this way you have to write. Next, if we take 2, then it 2 is a common factor of 6, 12, 18. Only these three are divisible by 2. In this next step, we can able to see that 6, 12, 18, these three numbers are divisible by 2. But we can also see that these all numbers are divisible by 3. So we can take 3 here. What we get? 3 3s are, 3 2s are, 3 4s are. This is 3 6 are 18. Next, this is 3 15s are 45. This is 3 9s are 27. Now next, children, here after getting these numbers, again we see most of the numbers we are divisible by 3. So again I will take 3 here. 3 ones are, and 2 is not divisible by 3. So I am writing this number as it is. Next, 4 also not divisible by 3. So I am writing this 4 as it is in the next step also. Next, 3 2s are 6, 3 5s are 15 and 3 3s are 9. After getting this step, children, now again at least 2 numbers should go in one table. That means at least 2 numbers should be divisible by the same factor. So here we are able to see that 2, 4 and 2, these numbers are divisible by 2. So I am taking 2 here. Now here 1, the same number I will take here, and 2 ones are 2, and here 2 2s are, 2 ones are, and here the same number I will take because 2 is not a factor of 5, so I am taking the same number, and similarly this one also I am taking the same number. Okay, children. Now here we can able to see that 1, 2, 5 and 3 numbers are left over here, isn't it? So these are co-prime numbers we got, because no common factor. At least two numbers also don't have any common factor. So here we got co-primes. So we can stop here. Now what will be our LCM, children? Here these all factors as well as these all leftover co-primes, if you multiply, then we will get our LCM. LCM is equal to 2 into 3 into 3 into 2 into 1 into 1 into 2 into 1 into 5 into 3. LCM is equal to 2 into 3 into 3 into 2 into 1 into 1 into 2 into 1 into 5 into 3. So if you multiply all these numbers, we will get 1080, 1080. So 1080 is the LCM of these all numbers, children. This is a short division method of finding LCM.